Hey guys, today we will be doing matrix multiplication. So remember last week we talked about matrix addition and subtraction and how the rules for those ones were pretty straightforward as long as you had the same size and same shape of matrix, then you could add and subtract them all you wanted. You could even set them equal to each other and just do space by space to solve for missing variables. So today we're going to talk about multiplication. For multiplying, there are lots of different new rules based on rules that you may have already known. But the easiest form of multiplication is called scalar multiplication. Scalar multiplication is super duper easy. You just take the outside number and you multiply it by each piece inside of your matrix. For example, if you're taking 2 and multiplying it by your matrix A, you're essentially doing 2 times 1, 2, 3, 4 in your matrix, okay? To find each answer, you would do 1 times 2, 2 times 2, 3 times 2, and 4 times 2. Now this step you can do in your head if you feel comfortable with it. Most people do not write it out, but I'm writing it out here in case you forget how to do them. 1 times 2 is 2 in this space, 2 times 2 is 4 in this space, 3 times 2 would be 6 in this space, and 4 times 2 would be 8 in this space. And that's it. You've got your final answer, okay? This is a 2 by 2 matrix. I multiply it by a scalar of 2, and I get a 2 by 2 final answer matrix. We can also use negative numbers and fractions. For negative numbers, you do exactly the same thing. 1, 2, 3, 4. And then your pieces would be 1 times negative 1, 2 times negative 1, 3 times negative 1, and 4 times negative 1. Now remember, you can skip this step if you feel like you've got it and you don't need to write out each one. So 1 times negative 1 is negative 1, 2 times negative 1 is negative 2, 3 times negative 1 is negative 3, and 4 times negative 1 is indeed negative 4. And that would be your final answer. Moving on. So now you've got scalar multiplication. That's the easy part, okay? Because scalar multiplication kind of looks like distribution across parentheses, kind of like you did with regular numbers maybe last week or so. So I'm gonna clear my drawings. I'm gonna move on to matrix multiplication. Matrix multiplication, that's the super duper extra complicated looking one that your book is gonna go all freaking out about, okay? It looks complex, it looks messy, and for it to work, the rows, the columns of the first one have to match the rows of the second one, and you have to use all this extra information. And then then that's just to find out if it's defined. And then the multiplication itself is even more messy than that. So I'm going to break it down for you into steps so that your life will be so much easier, hopefully. So first, it's to look at the size or shape of our matrix. For A, it is a 2 rows, 3 columns matrix, a 2 by 3. And B is a 1, 2, 3 rows by 1, 2 columns. Okay. So if we take column A, if we take AB, then if we multiply them together, it's a 2 by 3 matrix and a 3 by 2 matrix. Now, this is the tricky part. The columns of the first matrix have to be the same as the rows from the second. The columns, remember that's the second number, have to match the rows, which you have to remember is the first number of the second. If these two numbers match, then you can do multiplication, okay? And if they match, the product is these guys here, a 2 by 2 square matrix, okay? We can do the same thing in the opposite order, okay? So if we did B times A, then this is a 3 by 2 multiplied by a 2 by 3. Now we can check to see if multiplication is defined. So remember the columns of the first and the rows of the second. If those match, you can do multiplication. And if those match, This is your final answer size, a 3 by 3. Okay, so this looks a little bit different. Remember, back before, you have been drilled into your head that multiplication is commutative. It doesn't matter the order, you'll still get the same answer. In matrix multiplication, it's a little bit different because as you can see just by this part, this A times B is a 2 by 2, but B times A is a 3 by 3. B times A is bigger than A times B. So it does not equal the same thing. You have to multiply them in the order that's given to get the correct answer. So be real careful about that, that you're not switching orders. Okay? All right, we are going to move on to what does this look like in your book? Your book or your curriculum probably gave you this really super duper extra complicated looking crazy formula that looks like this, or maybe even something like this with color. Mine doesn't have color. I don't know why mine doesn't have color. And this looks very, very complicated. This says A, row 1, column 1, B, row 1, column 1, all the way up to A, row 1, column N, B, row N, column 1. It's very complicated. And then it like repeats over and over and over, and it keeps going, and this means goes on and on. It looks super complicated, but what it really means is this underneath. Okay, so it's super complicated. We're gonna make it easy. Take a breath, okay? First, we're gonna find the product AB for these two matrices, okay? How do we do it? Step 1, write them next to each other. So here we go. A looks like this, and B looks like that. Relatively easy, right? And then we want to make sure that we can actually do the math that they're asking us. So 3 by 3, the product is defined. Therefore, the size of my answer will be the outside pieces, a 2 by 2. So I'm already ready. I could essentially set this up with an equal sign, and I can write a 2 by 2 matrix. I know my answer is going to look like that. There need 4 different numbers. Okay. If I don't get 4 different numbers, then I know that I've done something wrong, and then you'll figure out where it was that I went wrong. Okay. So we're going to multiply the rows of A by the columns of B. Okay. Here's your stress notes. It's okay. I got you. Okay. I put every single step in here, so it's okay. So I'm going to rewrite these matrices so that when I scroll down, you can still see the original ones. So I'm just going to grab my pen tool, and I'm going to write A is 1, 0, -2, 0, 3, -1. And then I'm multiplying by 0, 3, -2, -1, 0, 4. Okay, I'm going to scroll down. Ready? Here we go. Take the rows of A, multiply by the columns of B. So we multiply the first entry by the first entry, the second entry by the second entry, the third entry by the third entry. What does that even mean, Miss Gracie? I don't know. Here, let me help. We'll put it in color because color will make your life a little bit easier. So the first entries by the first entries, okay? The second by the second, third by third. So what they're saying is the row of A, this row times this column, okay? So if I look carefully, 1 times 0 is 1 times 0. Okay, I'll grab a different color, not orange because I used orange originally. Okay, and then I'm going to go 0 times -2, 0 times -2. -2 times 0, -2 times 0. That row is done. That section is done. Okay, go to blue. So I'm doing I did the first row, row 1. No, I want to do it in green. That way it means row 1, column 1. This is row 1, and this is column 1 in my answer. So see how I have 2 rows? I'm going to put that one in blue. So I have a row 2 and a column 2, row 2, column 2. That gives me my 4 pieces. That's where your pieces all come from. Okay, so I'm going to do this one. Okay, I've got my row 2, and I'm going to do column 1 with this one. Okay, so I have row 2, column 1. So I guess I could do that with these ones as well to make it a little bit easier to see. So I think this is really important. Row 1, column 1. Now I'm doing row 2, column 1 again. So they're both in. So see how the green one goes here, and the blue one will go here. Row 2, column 1. Okay, so I have 0 times 0, 0 times 0. 3 times negative 2, 3 times negative 2. Negative 1 times 0, negative 1 times 0. Okay, new color, pink. I'm starting with row 1 again, but now I'm doing column 2. Row 1, column 2 will give me this space. 1 times 3. 1 times 3. 0 times negative 1. 0 times negative 1. Negative 2 times 4. Negative 2 times 4. Okay, and now we'll do purple for the last one. We're doing row 2, column 2. Row 2, column 2 will give me this space. All right, so we've got 0 times 3. 0 times 3. 3 times negative 1. 3 times negative 1. Negative 1 times 4. Negative 1 times 4. It may be helpful to do this step a few times in the matrices, just so that you get the process down. But eventually, yes, you can and probably will end up skipping this step. Okay, you usually write down as you multiply. So like 0 times 1 is 0. 0 times negative 2 is 0. Negative 2 times 0 is 0. Okay, then you just do each of the math. Negative 3 times 1 is 3. 0 times 1, negative 1 is 0. Negative 2 times 4 is negative 8. 0, negative 6, and 0. 0, negative 6, 0. 0, negative 3, and negative 4. 0, negative 3, negative 4. And now I'm going to add these all together. Okay. So here we go. 0 plus 0 plus 0 is 0. 0 minus 6 plus 0 is minus 6. 3 plus 0 minus 8 is negative 5. And then 0 minus 3 minus 4 is minus 7. Okay, so what did we end up getting? We ended up getting a 2 by 2 final answer matrix. But what did we expect to get? Did we do our math correctly? Well, if we look back up here, well, we don't really have to scroll back up. We can just check it really quickly. Remember, the check is, what did we start with? 2 by 3 and a 3 by 2. If these match, this was my answer. Ah, that's a really bad arrow. 2 by 2 should be my answer. And it was. We got a 2 by 2. So we must have done it correctly. So you did it. Yay. The only thing you really have to worry about is making sure that your numbers, you did your math correctly in your numbers. Okay. The next one I gave in is example, so you could do it again to get a little bit more practice. Let's see if you can remember the steps as we go through them. Okay. So first of all, we're trying to find the product B times A. So what do we first do? Well, first, we're going to just write down our matrices next to each other. 0, 3, negative 2, negative 1, 0, and 4. Multiplied by 1, 0, negative 2, 0, 3, negative 1. Can we do the math? This is a 3 row by 2 column. This is a 2 row by 3 column. So 2 by 2, that works. So I can do the math. What would the answer size be? I'm going to select this whole group and I'm just going to copy it and move it over here so I can, oh wait, I can just leave that there. Hold on. Okay, let me, because I want to keep these matrices so I can use them in the next part. Okay, so we can do the math. So then we're trying to figure out what the size of my answer matrix will be. And how do we do that? It's the leftover part after we do the checking. So 2 by 2 matches, so we can do the math. So then a 3 by 3 should be our final answer. We're going to have 3 rows and 3 columns. Okay, everybody okay with that? All right, any of your stress notes goes right there in the stress notes section. I'm going to delete this, I'm going to delete this, I'm going to scroll down so we can keep our matrix over here. Okay, we're going to be multiplying the rows of B by the columns of A. 1, 2, 3 rows, 1, 2, 3 columns. We're expecting a 3 by 3 matrix. Well, let's do this. Y'all ready? I'm so sure you're ready. All right, we got this. So the first thing we're going to do is we're going to do our colors. I'm going to do it in color, and then if you want to do it in color, you can do it in color too. I'm going to start with red. We're starting with row 1, column 1. Okay. In my big matrix, my answer matrix, I'm going to give myself lots of room because I know I'm going to need it. In red, 0 times 1 plus 3 times 0. Oh, well, that was pretty easy. New color. Row 2, column 1 again. -2 times 1. Row 2, column 1. -2 times 1 plus -1 times 0. I'm done with that one. Now it's green. Row 3, column 1. 0 times 1 plus 4 times 0. Okay. New color. Row 1, column 2. Row 1, column 2. So we've got column 1, column 2. 0 times 0 plus 3 times 3. New color. Row 2 times column 2. Row 2, column 2. -2 times 0 plus -1 times 3. New color. Row 3, column 2. Row 3, column 2. 0 times 0 plus 4 times 3. New color. Where am I? Orange? I'm in orange. All right, row 1 times column 3. Row 1, column 3 should be here. 0 times -2 plus 3 times -1. New color. Row 2, column 3. Row 2, column 3. -2 times -2. -1 times -1. Sorry, plus -1 times -1. New color. Row 3, column 3. Row 3, column 3. 0 times -2 plus 4 times -1. We're done. Now we're going to take each of these pieces and just multiply them to make our lives easier, starting back with red. That's my 3 by 3 matrix. It's just in case I need it. All right. 0 times 1 is 0, plus 3 times 0 is 0. How did I go from 0? Oh, I went down. Right. -2 times 1 is -2, plus 1 times 0 is 0. 0 times 1 is 0, plus 4 times 0 is 0. 0 times 0 is 0, plus 3 times 3 is 9. -2 times 0 is 0, plus -1 times 3 is -3. Purple, pink. 0 times 0 is 0, plus 4 times 3 is 12. 0 times -2 is 0, plus 3 times -1 is -3. -2 times -2 is 4, plus -1 times -1 is 1. 0 times -2 is 0, plus 4 times -1 is -4. Now we're going to do the final math. 0 plus 0 is 0. 0 plus 9 is 9. 0 plus -3 is -3. -2 plus 0 is -2. 0 plus -3 is -3. 4 plus 1 is 5. 0 plus 0 is 0. 0 plus 12 is 12. 0 plus -4 is -4. We got a 3 by 3 matrix. Is that what we expected? Always double check to make sure you did correct math. This is a 3 by 2. This is a 2 by 3. These match, and I expected a 3 by 3 answer matrix. That's what I got. Okay. Hopefully this clears up a bunch of the misunderstandings and the confusions. Feel free to screenshot this for your notes, pause, rewatch the video as much as you need to make sure that it does make sense to you. The last parts are animated explanations of these matrices, the exact ones we did. These are through Khan Academy, I believe, or another one. I'm not sure. Just kidding, it's through Purple Math. Okay, so multiplying matrices give you 2 different examples. Hopefully that helps you. The last thing you're going to need to go over is multiplying by the identity matrix. What's the point of the identity matrix? Remember, the identity matrix is a diagonal that has all ones in the diagonal and zeros everywhere else. It tends to give us an answer. So if we had the matrix A and we wanted to multiply it by the identity, that is A times I, you would need to use the 3 by 3 identity matrix. Why would you have to use the 3 by 3 identity matrix? Well, that's easy, because if you didn't use the 3 by 3, you wouldn't have the correct number of, so A is a 2 by 3, and you need something with a matching, you want an identity with a matching piece right here. If it's a 3 here, it has to be a 3 by 3. Therefore, my answer is going to be a 2 by 3 answer. Okay, so I start by a 2 by 3, and it makes sense because an identity tells you, like, it's like multiplying by 1. So it's not really multiplying by anything. Okay, everything will end up being the same because you're going to end up with a whole bunch of zeros, and you're only going to end up keeping that one answer. So if I took 1, 2, 3, 4, 5, 6 matrix A and I multiply it by the identity, here's all of the steps. And when we simplify that, if you notice really carefully, all of these pieces are zeros. They all end up going away. So I end up with 1, 2, 3, 4, 5, 6. I end up with the same thing I started with. On the other hand, if I wanted to multiply I times A, because remember back at the very beginning of matrix multiplication, I told you that AB is not the same as BA. Well, that means that A times the identity cannot be the same as the identity times A. If you're switching the orders of the identities in the matrices, you have to have a different identity for each one. But remember, identities can be anything you need them to be as long as they're square. So in this case, if we want to multiply the identity on this side and A on this side, then A is still a 2 by 3 matrix. The identity to match would need to be a 2 here. If it was a 2 here, this would have to have been a 2 by 2 square identity matrix. And that's indeed what they did afterwards. Okay, so they put this 2 by 2 square on this side to multiply. And again, all of those zeros knock out and you're left with just the original pieces that you had. Okay, this comes important later. It doesn't really help you right at the moment. Just like when we taught you, anything times 1 is itself, we didn't really care about that until we got into like fractions and solving for equations. Sorry, not solving equations, solving for variables, where you had to multiply by 2 or you had to divide by 2 to cancel it out on either side. That's what we're doing here with identity matrices. Okay, so hopefully this clears up all of the confusion of section, I believe, lesson 3 and 4, anything on scalar multiplication, multiplying matrices of any kind, and then identity multiplication. If you have questions, feel free to message me or ask me in class next time. And that's it, guys. That's all I've got for you. I will see you in class next time.